My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 207. In this lecture, we will try to understand why linear algebra is important for data science. First, let me define linear algebra in the context of data science. I can say linear algebra is branch of mathematics. It's a branch of mathematics that finds significant applications in data science. It is important to have sufficient knowledge of few linear algebra concepts if you are looking to understand the underlying concept. To underline, why do we need sufficient knowledge of linear algebra? To understand underlying, this is important, to understand underlying concepts behind data science. We need linear algebra. Linear algebra helps in creating better data science algorithms. You can build better data science algorithms. If you want to build better data science algorithms, this linear algebra is useful. You can use your learning of linear algebra to build better supervised and as well as unsupervised. Better supervised, I can say better supervised as well as better unsupervised. Better supervised as well as unsupervised machine learning algorithms. I can build better machine learning algorithms, better supervised machine learning algorithms, as well as unsupervised machine learning algorithms. Logistic regression, linear regression, decision trees, I can say decision trees, SVMs, or few supervised machine learning algorithms. Isn't it? You can create these algorithms. You can create these algorithms from scratch. You can build these algorithms. You can understand these algorithms from the scratch once if you have an idea of concepts in linear algebra. Use it for unsupervised algorithms like clustering. Clustering is a part of unsupervised machine learning algorithms like SVDs. All these things you can understand all these concepts from the scratch. If you want to understand the supervised as well as unsupervised machine learning algorithms from the scratch, you need concepts of linear algebra. Linear algebra will help you to develop more in-depth, I can say, with the help of linear algebra, you can develop a more in-depth understanding. Understanding of what? Understanding of data science projects. I can say like this. Data science projects. Once if you have basic concepts, if you are aware of basic concepts in linear algebra, you can execute data science projects in an efficient manner. I will continue my discussion. This is basic motivation. Why you learn before data science means I can say linear algebra is a very fundamental area. It's a very fundamental fundamental area in mathematics to understand data science. Fundamental area in mathematics to understand your data science. It is very, very broad area. I can say it is very, very broad area. Broad, very, very broad. I can say very, very broad area. But with respect to machine learning, we use it to solve specific types of problems. We will try to solve specific with respect to data science or with respect to machine learning. We will try to solve specific types of problems. Specific types of problems. Let me motivate you with very simple example. Let's assume I have two features. Let me say like this. I have two features. My first feature is, let me say, yes, F1. F1 is my first feature. This F2 is my second feature. Let's assume our famous data set, iris data set, which we discussed in my previous lecture. My feature 1, let me assume my feature 1 is petal length. My feature 2, let me assume petal width. We already discussed what is petal length, what is petal width, isn't it? Now, let me say like this. Let's assume I have two types of flowers. Let me say like this. This is one type of flower. I will repeat. Let's assume I have two types of flowers. One type of flowers marked with cross, and other types of flowers marked with circles. Let me call them circle flowers and cross flowers. Now, to separate these flowers, to be able to distinguish from one flower to other flower, what the methods we saw when we are doing exploratory data analytics, we could draw a line like this, and we could say everything on one side of the line belongs to class of flowers, and this is one side of the line. This is, I can say, cross flowers. Everything other side of the line, I can say circle flowers. It belongs to other category of flowers. We have two categories of flowers, cross flowers. Let me say circle flowers. This we could do it in two-dimensional. This is in two-dimensional, isn't it? In two dimension, isn't it? Imagine if I have to do in 3 dimensions, what would I do? Imagine if I have, let me say like this. If I have 3 features, what are those 3 features? This one is, let me assume, this one is F1, this one is F2, this one is F3, isn't it? This one is F3. Means I have 3 features, and your points were like this. Let me assume these are your points is like this in your 3 dimensions, isn't it? Now what I have to do? What I have to do? I could again draw a plane to separate these points. How can I draw a plane? I can draw a plane like this. Maybe I can draw a plane like this. Something like this. I can draw a plane like this, isn't it? What does it mean? This side of the plane belongs to one type of flowers. The other side of the plane, this is the other side of the plane, belongs to another type of flowers. If you speak strictly, if you observe in 2D, it's what's happening. In 2D, we are able to separate data points with the line, whereas in 3D, we are able to separate data points with plane. Isn't it? What about 4D, 5D, 6D, so on? What about ND? What about n dimensions? Isn't it? Now, whatever we learned Now whatever we learned in 2D, just observe this point carefully. Whatever we learned in 2D, 3D, do we generalize? How do we generalize this to whatever we learned in 2D and 3D? How do we generalize? How do we generalize? How do we generalize to higher dimensions, to higher dimensional spaces, to higher dimensional spaces, isn't it? We must be able to generalize this one, isn't it? Of course, we can't visualize data in, 4D, 5D, so on, ND. Isn't that's the problem. Linear algebra is a brilliant mathematical tool to understand 4D, 5D, so on, I can say ND. Linear algebra provides mathematical tools to help us to operate in higher dimensional spaces. Because in data science, in machine learning, if I have 10 features, let me say like this, if I have 10 features, if I have how many features? 10 features. In this case, I have 3 features, F1, F2, F3, isn't it? What happens in machine learning? If I have 10 features, I have to operate. If I have 10 features, I have to operate in 10-dimensional space. 10-dimensional space. As we had 3 features here, we were operating in 3-dimensional space. In similar manner, if I have 10 features, I must operate in 10-dimensional space, isn't it? If I have 1,000 features, let me assume, if I have 1,000 features, what I have to do? I have to operate in 1,000-dimensional space. In 1,000-dimensional space. Is it feasible thing operating in 10-dimensional space, operating in 1,000-dimensional space? Is it feasible? But of course, we can't visualize anything. We can't visualize 4D, we can't visualize 5D, we can't visualize ND. More than 4D or 5D, and hence, as we are not able to visualize, hence linear algebra, hence I will repeat, linear algebra provides us, provides us with the mathematical tools that we need to simplify or generalize. You need to simplify, or I can say simplify, or we can say generalize 2D, 3D. It is useful. Linear algebra is useful to generalize 2D and 3D. How will it be? I will discuss in future classes. Thank you very much.